Here we have a water tank that's in the shape of a cone, and we're given that water's being drained out, the water's coming out of the tank at a rate of 1.5 cubic feet per second. And so as water's coming out, the height of the water, so the height will be the distance from here up to the water. So the bottom of the tank up to the water, that's the height of the water. And so as water is being drained, or as water is coming out of the tank, the height of the water also changes, it also drops. And so we like to know how fast is the height of the water dropping. What is the rate of change of the height of the water? The volume of a cone is 1/3 times pi times the square of the radius times the height. And in this case, we are dealing with the height of the water. And so we also have two things going on right here, so we need to, so this would be the radius of the water. So it's r squared, but it's water. The cone has a height of 12, a radius of 6. And so the ratio of radius to height would be 6/12, which is 1/2. The water, which is up to this point, and then this is the height of the water, and then this is the radius of the water. And the radius, the height and the radius forms a right triangle. And so this shape right here also forms a right triangle. And this right triangle is inside of this right triangle. So they're similar. And similar triangles, they will have the same ratio. And so the ratio of the R over H is 1/2. Then the ratio of the radius of the water over the height of the water is also 1/2. So this ratio, radius to height, is 1/2. So ratio of radius of water to height of water is also 1/2. And so we cross multiply, then we get R times 2, which is 2R. And so 1 times H is 1H, which means H is equal to 2 times the radius. So we have H of water is equal to 2 times the radius of the water. And so we need to go ahead and put volume of water right here. And so the volume of the water now becomes this. And then right here we can, so if we, since we're looking for the how fast the height of the water is changing, and so we want to keep the H and just replace the R. And so from here, if we divide both sides by 2, then we get R of water is equal to H of water and dividing by 2. And so right here in the place of R of water, we have H of water and square. And this will be, and then we can expand this out. So if we square this, then this will become H squared dividing by 4. And so we get 112. 3 times 4 is 12, and then we have the pi, and then times, and then this is h squared times h, it'd be h to the third. And so the rate of change of the height of the water is what we're looking for. And so from here, we have this. And then the volume of the water is changing with respect to time. And then the height of the water also changes with respect to time. And so we need to do implicit differentiation with respect to time. And so this is the same as 1v. And so the derivative be 1, and then this is the variable v, and so we're doing with the derivative with respect to time, and so we have to multiply this by dv water dividing by dt with respect to time. And then on this side we have 112. And then the derivative of h to the third is 3 h squared. And then since the variable here is h and we're doing derivative with respect to time, so the chain rule says we have to multiply this by dh. Dividing by dt. So 1 times dv dt is just that. And then this is 112 times 3. So it'll be 3 over 12, which is 1/4. So this is the rate of change of the volume, and we're given that water is being drained at a rate of 1.5 cubic feet per second. And so that's what the dv dt is, 1.5. cubic feet per second. And then the dh dt right here, this is the rate of change of height of water. And we want to find the rate of change of the water, the height of the water, at the instant when the height is 6 feet. And so we have water dropping here, since we have water being drained out of the tank, and so at the instant when the height So this is when the height is of the water 6 feet. So at this instant, we'd like to know how fast is the height, what is the rate of change of the height of the water. So we're given that this is 1.5 since water is being drained out of the tank at a rate of 1.5 feet per second, cubic feet per second. And so this and then at the instant when the water's height is 6 feet. And so we have this is equal to 1.5 dividing by all of this. And we divide this on the calculator, it comes out to be about 0.053. And so the unit here would be foot per second. So at the instant when the height of the water is 6 feet, and then at that instant the rate of change of the height of the water is 0.053 foot per second.